Okay.
Right. Right, Yvette will tell us when we're ready to go, and then I will introduce me and you, and then I'll let you know after about 20 minutes, then I'll give you a chance to talk, Lenny.
20 minutes.
Okay. I'm not sure I can hold off for that long.
Okay, looks like we're live. All right, so welcome everybody. We're just still learning the technology, so it takes us, we're not always ready at 8 o'clock on the dot. We had to actually cancel it and start again because poor old Facebook's been a bit overworked at the moment. So welcome to our Wednesday night live, 8 o'clock. We've got myself, Caroline from Bubbly Maths. So at Bubbly Maths, our mission is that every child on earth will love learning and enjoy mathematics. And we do that by helping children stop hating, start learning maths so that they can live happier, more successful lives. And what can we do during this time? Well, normally we do workshops and shows in schools and festivals and events. We can't exactly do that right now. So it's occurred to us to do lives, and what we're doing is we're inviting people like the amazing Lenny, which and what Lenny does is he's an engineer, and he's not a formal mathematician, he's an engineer. So as us engineers have to learn math to become engineers. I'm an engineer too. Lenny's actually a practicing engineer, he's a working engineer, proper working engineer. Me, I haven't done it for years.
Yeah,
but Lenny's got his own way of he's passionate about maths. He's a maths enthusiast, and in his own time, he does a lot of activities in schools with children, tutoring and it's in his focus is the same as Bubbly Maths. It's making maths fun. It's finding the relevance.
Yeah.
And you love to find the relevance, don't you, Lenny?
Yeah, I love to find the hidden meaning within mathematics. So I have found that there isn't any mathematical concept that you can't break down and turn either into a shape or something of beauty, some sort of art. So I think I said to you yesterday, the black hole is nicely described by a trampoline with a very heavy object in the middle, and that represents the gravity of the pull. So almost any complicated concept can be described in a simpler fashion. So.
Okay. And today we're doing maths with everyday objects.
Yeah.
And that's, again, Lenny's come up with a couple of really lovely ideas, very simple. And one of them I had never even thought of. And I'm really thrilled because I can do this with strings of meter length balloons as well. So I'm super thrilled about that, to actually be able to facilitate using it as well.
You thought about that, yeah.
So Lenny, yeah, I thought about it. So Lenny, please tell us a little bit about yourself, why you do what you do.
Okay.
And go.
Right, yeah, well, I started, when I began, I was very young. So, and then I grew up and I learned to love maths. And I think I learned to love learning because I had some great teachers. They were either enthusiastic, or they were funny, or they were well organized. So you respected them for one of those reasons. And you learn, and I think I found that people learn in different ways. And I've done a little bit of teaching myself, or at least I call it sort of educating. And I also entertain. So I became an engineer, and that's putting things together and repairing things, taking them apart again, things like that. And that's where I think I've got my feeling for shape and patterns. And then a bit later on, I was asked to entertain for children and make them laugh. And through that, I've learned how to connect to children, how to get a message across quickly. And what I do now is I put the two together, my love for engineering and shapes and my love for communicating. And I call myself a laughter magician, or a laugh-matician now. And it works for me. I think I can make anybody love maths, especially if they say, I hate that.
Fantastic. Well, let me tell you, Lenny, that we have on board with us, we have Carol Bream from Northern Ireland. We've got Kate Oakdard, who is my YouTube special guru.
Hello.
And she's got two little children. Deborah Gary from the United States of America. She's a bubble artist.
US of A. Hi there.
And we have Fernando Blasco. Now, Fernando Blasco is another maths enthusiast, but he's also a mathematician, and he is a lecturer in Spanish University, in Spanish Polytechnic, doing maths.
That's put me in my place.
He's a mathematician. He's a published author. He's written a lot of books, and he's actually asked me to write one with him, which has taken a little bit long to come up with. Because
are these the ones I was doing your little sketches for? Is that the one? You asked me to do some sketches. I don't
have a memory.
No.
So you probably, Lenny, but I don't have
the answer is yes.
I can't help you. But Fernando, welcome. And Fernando, I would love you to come and do some of these as well, please. 8 o'clock every night.
Book me a place, buy me a ticket.
Yeah, quite. Okay, so what's our first activity there?
Right.
We would love feedback and ideas as well, please. If you've got time to stay here for the session, that'd be great. If you can do follow-ups and make comments, ideas if you've got, and links, if you have any links, Fernando.
Okay.
His English is excellent too. I can speak to him perfectly well in English, pero también le puede hablar en español, en castellano, but we'll stick to English. Stop because showing off.
You'll have to help me there. Right, well, yeah, so my mission, if there is one, is to help the kids that say they hate maths. I think what you need to do, you need to get in early and before they really think they know what maths is, because usually kids who say I hate maths or I hate English or anything, usually I don't get it. Usually I have either found out the wrong way or they've given up or whatever, and usually it's a case of try again. But I like to, and I know it works for a fact, I like to make mathematics fun. I like to get to the beginnings of it, find out where it came from, and that usually helps children. Now, so this is basically, it's fundamental math. It's more to do with shapes. And were you going to say something, Caroline?
Yeah, no, I want to see what you have, because you had a thing planned with, go on, with everyday objects.
Yeah, so I think a nice thing to do is just to play with objects and go and find anything. And I think you can go and find peanuts, basically just objects that look similar, and get satsumas or get coins or whatever, and just play around with numbers. Because
objects that the children love. So for my grandson right now, the object to use that will get him engaged instantly is monster trucks. You get the monster truck out, and that's it. You've got him. It doesn't matter what conversation you have with him.
No, that's perfect. And anything that you can put in order, that you can order and create pretty shapes. But because I think I've said this a couple of times since we've been doing this, that I think we understand shapes before we understand numbers. I'm fairly sure that seems to be instinctual. So I think so.
Yeah, because you see shapes and the shape's there. Whereas
the shapes are there and you don't ask questions.
Nothing.
That's right. You don't that's absolutely right. You don't necessarily know a square has got 4 sides. You just know it fits into a square hole effectively. So so I found some everyday objects. They're not that everyday, I imagine. These are actually ball pit balls. So I bought these for I've got no idea why I bought it, but that's not really the point. And what I'll do is I'll just count a few, and I'm going to move the camera just to make things a little bit easier. You tell me if you can see it or not.
It's got to go further back again, Lenny. We won't be able to see it.
Okay, so let's move things away. So
notice that he's used the lid of a storage box, of a plastic storage box. And you notice how he's put all the lines on there while he's getting the balls ready. He's got actually 10 lines on every spot, and he's put the lines on the raised bits too, so that if you find an object that's a size that will actually give you 10 in each slot, then you can use it for place value. And you notice he's got numbers written on the front, the end closest to us. So you've got numbers at the top there.
So they're your units or ones, so they're your tens, hundreds, and so on. So that's for slightly more advanced maths. But again, I don't ask children to count. I just ask them to play. So I'll just say.
But the resource works from a very early age, and it works, all the way through.
And I can't find. We'll do this another night. I'll find the counters, but that takes exactly 10 counters. And so if you want to count higher than 10, you're going to have to create a marker somewhere else. So we move to the next line and we'll put a marker down there. That'll count for the 10. And then we can carry on counting, which is what you do when your fingers, which is the decimal system.
And this is out of a lid of a plastic storage
Lid of a plastic
container.
box, which just luckily came together. That's the beauty. The beauty of...
Hi, Dee Dee. And hi, Stephen.
Hi there. So here are my everyday objects. And I've counted out 12 here. And what I would do, so if you had your child, I would just say to your child, move these around until you see a nice pattern, and then tell me what you think about it. So kind of automatically, things start happening there. You've already created lines before you've even started. I don't know if you can see that. So we've got a nice set of lines there. Set of lines there. So perhaps
the way I'm looking at it, I'm looking at it the other way. I can see 3, 4, and 4. Looking at that,
you can see lines this way.
So I'm seeing lines differently to the way you're seeing lines.
Yeah.
And you can have a discussion about all the different patterns you can see. You can see 6 balls around. Each ball has 6 balls all the way around.
Ah, you're right. So around here, if you call that a center, I think this will work. I think we can move this. I'm hoping, and I think
you can isolate it.
Is that a pattern? So you might call that a flower. You might call it a hexagon.
You can call it hexagon, and then, or you can make, then you can extrapolate it and see what happens if you expand it out some more. So you can create art out of maths, especially if you're doing it like this.
So I think a child would say flower. I'm sure they would. They would say flower. You said you're right. How many petals does the flower?
There's no right or wrong as well.
There's no right or wrong. So it's about
yes, and then ask the questions. How many petals? Yeah.
There you go. So then what you can say is, what would you call this? What should we write this pattern down as? And we might call it flower. If they're a little older, you just say hexagon, 6-sided figure. 1, 2, 3, 4, 5, 6. So 6-sided with a center. And you can, if they're a bit more advanced, you can talk about angles, but I wouldn't at this point. This is all about play. This is all about just creating patterns.
Remember, Lenny, that some of our parents aren't necessarily comfortable talking about angles and talking about hexagons. I mean, remembering...
No, don't do that. No, I would say don't do that. I would just say move things around and just create patterns and see what happens.
And have conversations together. Oh, look, yes, we've got another pattern. Have conversations together. And if you don't know the name of something, you don't know how to express it, we can find out together. Say, let's find out.
That's right.
Find out together. And then you're modeling learning, and you're modeling lifelong learning. So if you don't know something when you're as old as you're the child thinking there's old, because we're really old, aren't we? I mean, I'm super old. And if we are learning constantly, then the child will grow up.
This is about playing, and this is about getting them early. And I'm quite obvious that I'm trying to create engineers. We need engineers. And this is how you get them early, and this is how you get people to think about shapes and think about the qualities of the shapes, what the shapes do, and where you can fit them in. And you give them games like this to start with, move on to Lego, move on to Meccano sets and building sets. There's so many now, so many more. I've got a set of lovely cogs and wheels that do the same. But this is just the basic, right at the beginning. Let's just play. And I think I would ultimately do this for any age, just to start with, just to get a feel. So we'll just keep moving things around. And if you see another shape, just say, oh, I can see one. So that could be a shape. If you move it around and just create patterns. And yeah, that looks quite nice. And just keep moving things around.
I see the Concorde. I saw it a minute ago.
Oh yeah, that's right. Yeah, so that's a jet fighter. Yeah. Oh, that's brilliant. Yeah, really good. So we keep playing around and just keep. That might be a galaxian. Oh, I think. Oh, if you turn it this way around, I can just.
And
just
as
see.
you're doing that, you can observe observe the patterns. Talk about the patterns. You've got 2s and you've got 3s, and if you have 2 3s and 3 2s. How many have you got? And wait a minute, the whole time we've got the same amount of balls, and yet we're creating all these different patterns and all these different structures.
That's correct. So we're not really getting anywhere near mathematics at the moment. We're just playing, which is the whole point. And we'll sneak maths in at a later date. So carry on.
We are experiencing mathematics.
We are experiencing it without knowing it, and that's sort of the point. So there's another pattern as well. So we just keep moving things around. What if we only use
anything? We're just what you call manipulating.
That's right.
Prior to even thinking about
anything. We're just moving things around, and so I've decided to don't use the in-betweens, use the every other group, and I've created a pattern there, I think.
No, I think you have. And that makes it really easy to work out how many balls there are.
Yeah, so now you could count if you wanted. You could say, how many lines have we got? And so we've got a counting exercise, 1, 2, 3, 4. And you say, great. And you say, how many balls have we got in the first one? 1, 2, 3. What about the second? The same, 1, 2, 3. How many in all? Oh, they're all 3. That's what you'll get straight away. So we've got 4 groups of 3. Oh, that's great. How many did we have in all? And we count 1 to 12. So, oh, well, so that must mean that you can create 4 groups of 3 balls.
I have to say,
adds up to 12.
I have to say hello, Sarah, and hello, Vicky. I haven't spoken to Vicky for years. Sarah's my lovely niece in Portugal. Now I've got 2 people in Portugal on.
Lovely.
Sorry, go ahead.
So we carry on. We just keep playing around, just keep moving things around and see if anything happens. And I'm just looking for pleasing patterns.
Well, I like that because you had 2 lines of 5 and 2.
Oh, you like that? Okay.
I like that. I had the
what
2
was that? Was
and
it
the
that?
2 lines of 5. I like that one.
That one, 2 lines of 5. Yeah, it could be 2 legs. There you go. There's your legs and there's your feet. So we call those the long legs. What about if I put these here? They don't quite fit, but I think we'll just about get away with it.
They look like caterpillars.
Yeah, 2 caterpillars, and we've got 2 lines, and they're the
caterpillar
same.
maths.
Caterpillar math. Why not? There you go. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 lines. So 12 is also 2 lines of 6. Brilliant. Okay. Let's move around. What about 1, 2, 3, 4? So we just keep moving until we create patterns. So
and now we've got 4 lines, 3 lines of 4. And
3 lines of 4.
That and the 4 lines of 3. Do we still have the same amount of balls?
So we'll have a piece of paper and we'll be writing these down. Maybe we can call this 3 times 4, or 3 lines of 4, or 3 columns. You can give it. Do you just want to give it a name that you can remember, and then that calls.
And what you just said, record it. Find a way to get a piece of paper, write down, and it doesn't have to be written in numbers, in numerals. It can be simply recording the way that you've patterned all the balls and just have them drawn out.
Well, you're kind of steering away from the numbers at the moment, because we've created other shapes. We've created jet fighters, we created legs, and we created flowers and everything else. And all you're doing really is you're showing that shapes sometimes occur in nature, and sometimes they just happen. They just fall into place. These balls, if you push them all together, they'll create equilateral triangles because they're all the same size. So things happen naturally, and that's kind of what you're doing. You're kind of playing around with nature, and it's kind of making sense that you're doing a bit of science as well. You're ultimately doing science. These are crystalline structures we're playing around with. So so things like ice is formed. You've always got 6-sided snowflakes, and that's because of the position of the electrons that run around the atom, and it just creates that perfect angle that creates a 6-sided figure, and it's built on. And that's what we're doing here. We're just, what happens, this sometimes is why it happens in nature. So we've got a pattern. We're only playing around with patterns. We're not too worried about numbers, but numbers are occurring as well. So it's great. So it's just,
if they choose to record with numbers and that's their choice, then it's not.
Do it as well. Do it as part of it. So yeah, and the whole thing is you'll have a mix of shapes and you'll have a mix of numbers, and they are all ultimately the same thing. So you can get to a solution in different ways. So really, this is a pattern for me.
And if the child does recognize, or you recognize something that does occur in nature, and you want to know why, Google it. And you can Google it as a family, and it's not, and the good practice is not for you to find out and then teach the child. Good practice is to find out, either get them to find it out and then talk about it, or
So
together.
and I'm very keen on letting a child discover and the child play. So you should maybe not move the things around, just get them to move it until they said, I found it. So I think that works, because then they build up confidence to explore.
Questions, and then of course having digital cameras these days and phones, you can take pictures,
You take pictures. That's it, and then at the end of the day, say, right,
document.
That's perfect, and that's what you do. So it's all about playing, and we're sneaking maths in. That's what I keep saying. We're sneaking it in and it's too late. By the time we've done it, it's oh crap, I've learned something. There we are. So we can keep moving around.
And I think we've got the idea there, Lenny. Shall we move on to the other one? Because time's ticking.
Brilliant. Okay, so we didn't do that one. That was our last one.
We've got, there you go.
Perfect. So everyday objects. All about playing.
6-2.
Now, this I think you thought was a bit of a revelation. Okay.
This was, it's one of those things that you think, why didn't I think of that? And I never did. And I use, in the workshops I use strings of really long meter length balloons, lots of lovely colors.
Yeah.
And this works so beautifully for that. It never even occurred to me. And I
I think this is ancient. That's what I believe. And it goes back, the Greeks knew about it. And I think before him, I think his name is Aryabhata. And he had a feeling that there was a relationship with triangles, and I think he did something to do with pouring water into ponds. But basically, just draw a triangle like that. So is that clear enough?
I was wondering why it was sounding a bit weird.
Just found where my headset was plugged into. Nowhere, the ozone.
I'm glad you did that, because I'm glad you stopped, because I just realised that my swear wasn't going to work. So thanks for that. That was fortunate.
Okay, you're very welcome.
Yeah, so there we go. That was
We're plugged in now. I'm plugged in now.
Fortunate accident. Okay, now this is triangle.
Yes, that's right. Were you doing it the wrong way round?
No, I'm not. No,
never mind. Ignore me.
No, definitely not. No, because we practice this, we rehearse this. We do rehearse these, by the way.
now, I want to just say before he starts that what Lenny's about to reveal is, as an engineer, as someone who went through the school system, learning the traditional by rote traditional systems and algorithms, the way probably many of you grown-ups learned. Is I'd never occurred to me. It never occurred to me. I just knew how to work out the length of these sides with relation to each other on a right-hand angled triangle. I only knew them as a formula. That's it.
So you learned
it as a formula. I was taught it as a formula. I learned it as a formula. I had to remember the formula, which of course I didn't. And now you're going to see.
So ultimately, you had a mathematical mind. You were one of those lucky people that could remember formulas. Not everybody.
No, I'm saying no, I wasn't. That's what I just said. No, I didn't remember them. Nothing. Zip.
I think you learned the words, but I don't think you learned the meaning.
Which is very, very common. So if any parents out there think, I don't really understand maths, it's because maths teaching, the learning of mathematics is evolving. Fernando that's on, he is a big, he really understands how to learn mathematics, and that's how he teaches it. But most teachers haven't learnt that, because it is an evolving science, it's an evolving skill. And so a lot of us, when we learnt at school, we didn't learn the way we want our children to learn.
Well,
so we're doing to help you facilitate for them. Go on.
Well, if I was a serious teacher, this is how I would do it. I'm not, unfortunately. I'm just silly.
No, you're just a silly teacher. Yeah.
I'm a silly teacher, but I think you can still learn from being silly as well. So this is a right angle, or it's 90 degrees. Why is it 90 degrees? Because we've decided to call that 360 degrees. We've just divided a circle into 360 points. And if you divide that 360 by 4, you end up with that quarter being 90 degrees. So there you go. So that's a 90 degrees. And we've decided that this triangle here has 90 degrees right there. Okay, so that's a right angle triangle. This bit here is a right angle. And you think a lot of people have learned this at school, whether they remember it or know where to use it is a different thing. So you have a square on there, we put a square on there, and the square means that the length along the top is the same as the length down the side, so it's a square. My drawing's not brilliant, but
now if any of you do remember a squared plus b squared equals c squared, you don't have to remember it.
You don't. Okay, so we've got a there, b there, and c there. Now these are squares, and this works because of the relation. So basically what this means is that because of these, it can't do anything else. So you've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And if you add 5 times 5, that will be 25 squares. So 16 plus 9 equals 25 squares. So that's more or less your proof.
Oh,
Still
are we
there?
still on then? Oh,
I can
okay.
see you went off for a second. So basically what we're saying is you've listened
We haven't heard, we didn't go off for a second, Lenny. We've been off for about 2 minutes. So
okay.
So,
all right, then,
so we get the concept. It's a 3, 4, 5, and
3, 4, 5.
And there's a 5 square, which is 25. 3
okay.
square, which is 9, and
Yeah.
4 square, which is 12. So those are
those
square
two
numbers.
add up.
That's another thing. If you ever hear the expression square numbers and wonder what they are, square numbers are the result of a number being multiplied by itself. So 5 squared is 25. Yeah. The 25 square number, and 16 is a square number. 9 is a square number because they're two numbers multiplied by each other to get them.
That's it. So, now, so what use is that? Nobody uses it really, except I'll issue a challenge, and this was a challenge that I think I gave to you. How can you create with a piece of string? So that was my challenge to you yesterday.
Steve said it froze at the exciting point, Lenny.
Ah, okay. Right. Well, we've got to. You missed the boring bit, which is explaining Pythagoras theorem.
So Steve and Lenny and I do bubble jamming. We're bubble enthusiasts as well as.
Not everybody actually knows what that means. That means you make giant bubbles. You mix giant bubbles.
We managed to put ourselves in a bubble at the same time. All three of us in a bubble at the same time.
Yeah, I pretend.
We tied ourselves in a knot.
That's right, like I'm doing now. I pretend that's science when I do that with kids.
What you're pretending science? It's engineering. It is science, absolutely. You've got to have the bubble mix right. You've got to have the right rig. You've got to build the right rig. You've got to have you got to assess the environment. You've got to assess the weather. Oh, it's absolutely science and engineering.
A lot of science in math. So here we go. So now I've got a piece of string. This is about roughly 2 meters long, and I've tied a knot in it. And I'm going to create a perfect right angle with this. Right. So before I carry on, I'm just wondering if anybody out there can work out how we do it. So this is how I explained it to yourself, Caroline, yesterday. So we need to create 12 knots. Why do we need to create 12 knots? Because on here we have 1 point, 2 points, 3 points, 4 points, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 points around that loop. So I'm going to create 12 points on my loop. And there's a couple of different ways you can do it. There is a slightly easier way I found out, which is just to tie knots at equal distance, but this is how I like to do it. It's a nice quick way. So what I do is I hold my finger on a knot at the top, and then I pull the strings down, both at the same tension, and I have the other end. That other end I'm going to mark. So I get my white pen and I put a mark on there. Great. Okay, so now we have 2 lengths That's the same. If I fold that in half again and pull down, I've got 4 lengths here, 1, 2, 3, 4, and I make
now
a
you've
mark.
got 4, right? So you got 4 marks.
4
I'm just going to
lengths.
interrupt for 1 second. We've got Kate
Okay.
says she's loving what we're doing. She says it's turning into a voyage of more discovery for little people. That I think we were on the balls. I think it was on the balls with that. And then Anne, just let you know, Anne is on from an old school friend of mine from Philadelphia. So hi, Anne.
Oh, hello.
Okay. Oh, and Erin from Australia, and Terry, my lovely friend Terry as well. Thank you for joining us. Right, sorry, just letting you know who's on. I've got and letting people saying hello. Thank you. Sorry, you may proceed. You have 4 lengths and 4 markers.
Okay, so you might notice I can't see the marks at the moment. When I showed this to yourself, Caroline, first, I did it with white string and I was using black marks on the string and they were easy to see, but this doesn't matter. We can get away with this. So I have it folded in half to begin with, or the string pulled tight. That creates 2 lengths and I fold it in half again. Now I've got 4 lengths. If I've got 4 lengths, I mark the top and the 2 bottoms. So now I have 4 marks on this piece of string, 1 on each end and 1 in the exact middle. So 4 marks. That'll be the 4th mark along there.
Right.
So now
so we
need to get the other. How many more marks have we got?
So we've got 4 out of 12. Okay, 8. We need 8 more.
Need 8 more. So there's a quick bit of subtraction. So what I'm going to do is I'm going to divide this into 3 lengths, 3 equal lengths. And the way you do that is you give it a twist about 1/3 of the way down, and you grab it where it crosses and you let it drop. So now I've got a long length and a short length. Okay, and this is about 1/3 of that roughly. Doesn't matter if it's exact. Cross it again.
Have you ever attempted, sorry, I'm going to pause there, because I mean, if you've ever attempted to fold something in 3, Lenny is showing you something really useful here. And another day, we're also going to show you how to fold a straight line, something that's straight like a tie or something. Yeah. For me, it's balloons. I need to be able to fold balloons in 3. So this is a loop folded in 3. And then,
this is a loop folding in 3.
But there's also a really neat trick for
that's right. This is how I divide this into 6 effectively, because although I'm dividing it into 3, we're talking about 2 lengths. So I'm going to divide it into 6, which is great. So once you've got, you see, so I've got a big loop and a little loop because I held the cross. I cross it again like that. If you can't see it, let me know. So I've got another cross.
No, we're good.
Here.
We're good.
Okay, and you just hold it. So you've got a big loop there. And if you put your fingers through everything, I now have 3 loops.
And then I'm like, okay, so how do we make it exactly right? And just watch.
Okay,
just watch.
You just give it a little pull and you keep on shuffling the strings and you move it with your fingers and they'll all be the same length.
Beautiful.
Beautiful. So there you are. So what does that mean? That means that at the top here, we can make another 2 marks right by the knot. 1, 2. So we've got 2 of the marks. And if you flip it over and make sure nothing moves and pull it tight, we can make another mark. 1, 2, 3. So now we've got 6 marks there. Well, you don't stop there. Keep hold of these. And
so how many we've got? 6 and 2. So now we've got 6 and 4. We've got 10 marks now.
10 marks. I think we got 10 marks. That's right. Yeah, I think so. Oh, yeah, that's right. And you'll have a couple of knots here, but you'll have a couple of marks here. And all you do is you fold that in half again. Okay, and you make sure you shuffle so everything's the same length, and you'll have 2 of the pieces with no mark on it, and you mark those out. So now all the way round. So what I've actually got here, hard to see, is I've actually got 12 different lengths, and they're all the same because I pulled them all to the same length. So I've got 12 marks which are equidistant apart, starting from the knot. Okay, so you let them all go. Okay, you undo your knot, and on every mark you tie a knot. And in true Blue Peter fashion.
Yvette just hit me. She just hit me. I was touching her phone. She hit me. Oh, we haven't introduced Yvette. She's our producer.
She's our producer, Yvette.
If anybody deals with bubbly mass, this is Yvette.
Without Yvette, we would not exist. We wouldn't be here.
No, without Yvette, I tell you what, bubbly maths would not exist. That's
that's
sure.
I bet. So where are we? So now this is my knot. I fast forwarded and I tied 12 knots.
Sorry.
So you missed that, didn't you? You were looking the other way, weren't you?
Magic.
Yeah, that's magic. You were looking the other way at the wrong time. That's what magic's all about. Okay, so we got 12 knots. Starting from there, 1, 2, 3, 4, 5, 6 down that way, and 6 up. So we've got 12. That's brilliant. So how do we turn that into that? So this is the bit I think is clever, and I don't know how or why I found this up. So I get my fuzzy end. This is my fuzzy knot, and I'll put that over a door handle or a knot, something to hold it. So it's over there. Okay, I count 4 along the bottom. 1, 2, 3, 4. Count 4 knots. 1, 2, 3, 4. I hold that knot there. Now I count up 3. 1, 2, 3. 1, 2, 3, and I hold it, and I gently pull it out. Still.
Did you hear that?
Was that a sharp intake of breath?
That was a really sharp intake of breath. Was like, it was
I was literally amazed as well when I first found that. So it's just, I only like it because it's beautiful. That's really, like yourself, Yvette. So that's exactly
I was
why
like
I do
that last night. I was like, we've got to do this. We've got to do this. We've got to do this. Absolutely love it.
Obviously, it's absolutely useless here. I can't stand here. This isn't going to be any use at all. But I could take this downstairs and I can create a perfectly square pond. I can get a peg and I can put it in the ground. Shall we do this bit? Because we did this bit.
Yeah, go for it. Yeah, let's do that, and then we're done for the night.
So we've got that. This is my right angle maker. So we know to make right angles. If you know you can make right angles, you can make perfect squares.
So if you know you can make right angle, you make perfect squares. Just pause 1 second. Texas is on the line. We have Houston, Texas. Houston, Texas. Can you hear us? The lovely Lorraine is on the line.
Hi there, coming in loud and strong. So we get our right angle maker. There's our right angle maker. There we go. This is our 3, 4, 5. Okay, and if we want to create a pond that's 20.
Oh, hello, Bryony. Sorry. We've got
meters. That's okay.
We've got Kate's eldest daughter, Bryony. Are these angles? Yes, these are angles, Bryony. They're right. We've got some right angles. We have some other angles too.
So, should we pick on angles? Let's do angles another day.
Yeah, we're going to do, let's know if you want to do angles, Bryony. But these are most certainly angles. We're only looking at the right angle. We're not deciding what the other angles are. But right now, it's just the right angle. And we're going to see if we can make a square. And maybe you guys could do that.
And today's...
Right. Wait. Bryony says that right angles are 90 degrees.
And how do we know that? So going back to what I said,
know that?
How do we know that? Why 90 degrees?
Bryony might not have seen it earlier. Show it again. Yeah.
So there's a cross. So if I start here at 0 and go all the way round, how many degrees in a whole circle?
Do you know how many there are in a whole circle, Bryony? So these are sort of conversations you can have with your children, by the way.
Yeah.
Grown-ups, parents. Not that Lorraine needs to have these conversations. Her kids are practically flown.
Or another way of doing it is you could say that's 90, because she knows that, and that's 90, and that is also 90, and that is also 90. So you could add all those together. Oh,
we've got 360. Yep. So we've got.
We know that.
The answer is 360, and then he's basically divided the 360 into 4 segments, 4 quarters.
4 quarters.
And each one is 90 degrees. So
90 degrees.
So there you go. So we got that 90 degrees, and now we're going to create a square using our.
Did Bryony see my magical right angle maker? Did she see that bit? So there's me fuzzy.
Yes, she saw it. Yes, no, Bryony.
Okay, so we know. So that's my right angle maker. I'm going to take that downstairs, and I'm going to use that to make. Right angles. So I took my right angle maker downstairs. There it is. There. I put a little peg here in that end, and I pulled the string out tight, and I created a right angle, and I recorded it on the ground, either by chalk or by a piece of chalk, and I drew a line along the side. I drew the line where the string was stretched taut, and I also carried that on along the bottom. Now I can choose to make this any length I like.
Right. So sorry, Bryony. So you saw what he did with the 90 degrees, right? How he made the 90 degrees with the circle. Yeah. Sorry, she saw that. It was a good thing we repeated it. She didn't see it earlier. Right. Okay. Keep going. This is where we're going to make a square with we're going to show. You can show the rope one more time, because I'm not sure that Bryony did see it.
Okay.
Thank you for your forbearance, everybody else.
Thank you. No. Yeah. Okay. So I count. There's my knot. This has 12 knots in it. So did my right angle triangle, which is 3, 4, 5.
And each one of those knots is exactly the same distance apart.
Okay, and I think plumbers know this, and a lot of builders know this. If you have a triangle, a right angle triangle that has a side of 3, a side of 4, and a side of 5, it creates a right angle between the 3 and the 4. So
and they use this in the ancient world to make right angles, to do
1, 2, 3,
construction.
4. So I have it there.
Long time ago.
You might be able to make out the knots, but I've got 4 along the bottom, I've got 3 up the side, and that automatically, and I've got 5 along the middle. I could add more actually, but if I keep that 5 in along the top, which we call the hypotenuse occasionally, that creates a right angle. It can't do anything else. That's the way right angles work.
You could make that your project tomorrow. You could make a string up like that.
Get a piece of string.
And then when Mummy's finished on the calls tomorrow, you could go out and make yourselves a square.
Yeah, I'll show you when we've done this. I'll show you a slightly quicker way to make that
living room floor.
So anyway, so that's my string. That's my right angle string, which I know I can do. I put a peg down here, and then I create a right angle. Once I've drawn that right angle on the floor, I can extend the sides to any length I like. So just for instance, we're going to do a 10-meter length. So I'm going to get one 10-meter piece of string, and I'm going to measure it out to here, 10 meters. There we go. So now I pick up my right angle maker and I bring it up this end and I flip it over 3, 4, 5, and as long as I stretch it out, I've created another right angle here.
Okay.
So there's a right angle, and now got another right angle. I still use my 10-meter piece of string and I stretch it along there and I draw 10 meters up there. So I've got 10 meters here. I take my right angle maker up here, stretch it out like that. There's my right angle, and I get my 10-meter piece of string and I stretch it out there.
Whoa, a 10 square meters. That's a pretty big.
Meter.
You might not have the room to do that in your living room, Bryony. You might have to make it a bit smaller.
You'll definitely have to go out in the garden. And then I'd do one more.
If they've got one, we can't assume they've got one.
Well, I like luxury. So there we are.
If you're watching this years from now, we're actually in the middle of the coronavirus time. So we're all actually housebound.
All going slightly mad.
Making history here.
Okay. Right. Now, great. Okay. So that's quite good. So 10 meters. How do we know it's square? We hope it's square. We've used our right angle makers, but there is a way.
Hold on. Oh, Zoe. Here's Zoe. So Zoe's the younger of the two.
Zoe.
So let's see what I think let's count how many, because every angle in a square, Zoe, is a right angle. So how many right angles are there in a square?
Oh.
Because that's hold on, don't answer it, Lenny. I'm asking.
I was going to count.
It's
1, 2,
we'll let her.
4, 5, 6.
I didn't give her a chance. Oh, you did. Keep going, Lenny. Keep going. You're all right.
I've counted 1, 2, 3, 4, 5, 6, 7, 8, 9.
And we'll leave it at that. We'll let her have a conversation with Brian.
I might have done that wrong.
You can work it out, Zoe.
Okay, by purpose.
So we've made the square, 10 meters.
We've made a square.
We are going to have to wrap it up. Can we just please show Zoe and Bryony the string one more time to make sure they've seen it?
Okay, doke.
If you go back, if you play this back tomorrow while Mummy's at work, you can see how to make it.
Right. Can I show you a slightly quicker way? A slightly quicker way to do that string. I only did that because it's mathematical, but there is a slightly quicker way. So I tie one knot here, and I tie another knot here. I make it about, let's just say, the width of my hand. I tie another knot here, and I shuffle it up and down until it's exactly the same length. So those two are same distance apart. And I can carry on down the string, making sure they're all the same distance apart as the first string. So
now always go back to the first one, because otherwise you'll be adding errors. If you go from the last one you made, what happens is you compound the errors. So always measure it back on the very first one you did.
So all I'm doing is I'm going along the string and I'm making sure that every knot is the same distance apart. And I'm doing that by using the first knot. So
Okay,
As long as
so
you,
you just
as long as you don't put your knots too far apart, then you should be able to get 11 knots on the string and a little bit left at the end to tie the last one together. So I can carry on down that string until I've got 12 knots.
Use a string that's longer than you need, a lot longer than you need.
Yeah,
Right.
yeah. The larger the string is, the more accurate your right angle is going to be.
Okay.
Okay, and there you go.
Also,
And then this has 12 knots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I always get the fuzzy end. I call this the fuzzy end because it's a bit fuzzy. And I hang it over the knot and I count 1, 2, 3, 4 along the bottom. That's what that is. And 1, 2, 3, 3 at the side. And, oh, I've counted too many. 4 and 3. And I make sure that the knot is right on the handle or on the peg. I stretch it, and that will make a triangle every single time. Let me see if I can. Oh, that looks pretty good. So
yeah, that's
mixing up in my
you get the idea.
tetrahedron. Sorry, that's
And if you draw it out,
there
there
you go.
Tetrahedron.
There you go. So there you are.
Fantastic. Okay, well, thank you, Lenny.
Okay.
Right.
Could I just say, just the last one?
Yes.
Just here. If your square is slightly out one side, you just get another piece of string and you measure it along there. And you don't change, and then you cut it exactly the same length and you bring it to the other two corners and it might not quite reach. And if it doesn't quite reach, that means that your square has tipped slightly two sides. You know they're all right. So you can use another piece of string, not your 10 meters, it's a longer piece of string, to measure between it. And you keep moving your squares sideways. You keep moving it until you get it perfect, and then when you've got it perfect, you've got a perfect square. So there is a quicker way to do this, but I just like this because we played around with maths and we've used everyday objects and we've created a little bit of magic and a little bit of fun.
Fantastic. Thank you so much, Lenny.
You're very welcome.
So we'll be here tomorrow night, 8 o'clock. Please join us. Please tell everybody else about it. And there, you'll look in the comments. We'll put another one at the end with the on YouTube channel. So all our videos are going to go up on the YouTube channel as well. And so there's lots of other resources on there. And
can we do angles tomorrow?
Let's think about it.
Yeah, let me play with angles. I've got so much I want to tell you about angles.
Okay, all right, Bryony, angles tomorrow apparently. So there you go. So thank you so much, Lenny. This is amazing.
Thank you.
So please do encourage people to come to the group, get them to join the group. And
if you've got any suggestions, please throw them in.
Yes, questions. If you've got questions
or suggestions,
we'd be delighted to help you with specific problems that you're experiencing at the moment. If you've got suggestions, if you've got links, if you've got ideas, if you've got pictures you've taken of activities you've done, please put them in the group. And it's all about supporting each other during this sorry, I'm going to get hit again. I've touched Yvette's phone. I've touched my phone. I'm allowed to touch my phone.
I hope we've made it fun for you. So good night again, and remember, hug a number, and we'll see you the next time. So thank you very much.
Hug a number. Good night. Thank you, everybody.
Bye-bye. Thank you.
Bye-bye.